we're now going to talk about a very important and very interesting type, which is called option. So let's make a function to that effect. Now, option is a type which indicates the presence or absence of a particular value, because sometimes a function might return you a value. Like, let's say you have a vector and you want to get the last element. If you pop the vector, it might return you a last element. But the question is, what if the element is empty? What if the vector doesn't have any elements? How do you indicate the fact that there is no element to return? Well, for that, we have a special type called OptionT, and this type is used all over the place, and Rust actually makes special provisions for this type, making it even more convenient to use. So let's take a look at a very simple example. Let's suppose I have two values. Let's say I have x equal to 3. Let's say I have y equals to 2, for example. Now, suppose I want to divide x by y. So in most cases, the division of x by y works just fine. But if y is equal to 0, for example, I will get infinity. And let's suppose that I want to avoid this. So in cases where y is equal to 0, instead of returning a result, I want to indicate that I'm not returning a result. How do I do it? Well, let's define our result. Our result is going to be conditional on whether y is equal to 0 or not, and the type that we're going to return is going to be an option of f64. I'll use f64 as the type for our calculations. So this option type, it's a std type, it's built in, is going to be defined something like this. So we put an if statement here. We say if y is not equal to 0.0, then everything is okay. And in this case, we can return a value. Otherwise, and I'll fill in the empty brackets in just a moment, otherwise we don't return a value. So option is actually at any time one of possible two states. So option can either contain a sum or it can contain a none. So a sum of z means that there is an answer and the value of the answer is z. None means that there is no answer. So if y is not equal to 0, then instead of returning just x divided by y, we return a sum of x divided by y. Otherwise, we return a none. Okay, so let's actually try just printing out the result using debug output and see what we get for different values. So I'm going to print out the debug for result. Let's Control F5. Let's just, oh wait, what's wrong here? One moment. Oh yeah, we forgot the semicolon here. Okay, so go again. Hopefully works this time. Okay, so we get a sum of 1.5. So we know that the division is valid, and the result of this division is a sum with a value of 3 divided by 2. Now, if I put a 0 in here and run this, what I will get is a none. It's basically saying, no, you cannot have any value at all. And now the question is, well, how can you sort of destructure? How can you actually get the result of the option as a value? Let's suppose that you know that both of the values are valid, like 3 and 2, and you want to print them out. Well, one of the kind of straightforward ways is to use a match. So you match result against either sum or none, and you're saying, well, if I have a sum of z, then obviously z is the result of the division, and I can print it out. So I can do a print line. I can say x divided by y is equal to z and specify x, y, and z. That's okay. However, I wouldn't be able to just compile and run this because I also have to cover the other option, the option that we got a none instead. And in the case when we had a none, what I can say is something like, let's do a print line as well, cannot divide this by this, where the first is x, second is y. Okay, so let's now run this. And in case of 3 and 2, 3 divided by 2 is equal to 1.5. That's okay. However, if I change it to a 0, then we cannot divide 3 by 0, and obviously the result is none. Okay, so one kind of convenience mechanism for figuring out if you do indeed have a value that Rust provides is an ability to do if let and while let. So when you use an if loop or a while loop, for example, what you can do is you can try and perform variable initialization right inside the condition. And depending on whether it's some or none, you will either execute the if statement or you will not execute the if statement, or the while loop in this case. So let me give you an example. I can write something like if let sum of z equals the result, do something, print line the value of z. So what does this mean? Well, basically, let's go through this fairly slowly, and I should be putting a semicolon in here. So let's go through this slowly. First of all, what happens is we get the result, which can either be a sum or a none, and we destructure it into z. So we say sum of z equals result. So if the destructuring works, the if condition holds. So if the destructuring did in fact give us a sum of the value, then we execute whatever the body of the if statement is. However, if the result is none, then this does not match this, the if condition doesn't hold, and therefore we don't print this value. So if I change this to 2, for example, and I execute this, the if statement gets executed, I get my z equals 1.5. However, if I change it to a 0, this statement, the if statement, doesn't get executed at all, as you can see here, because essentially we didn't match the condition for the if, meaning that if your destructuring fails, then the if or the while treats it as a false, which is super convenient, and it's a special provision made for you by the language.